Hello everyone, my name is Bart Levengood, and today I will be discussing the changes in deep water formation in the North Atlantic Ocean and how they occur. To begin, I'd like to discuss where deep water formation occurs and why it occurs. So, in the Northern Atlantic, deep water, deep water formation mainly occurs in the Nordic Seas and the Labrador Sea. In the Southern Atlantic Ocean, it occurs mostly in the Weddell Sea. They occur for many different reasons, but the main reason in the North Atlantic is this warm water moving up the eastern coast of the United States and North American continent has a very high salinity. This salinity maintains itself moving up into the Nordic seas, but the temperature slowly begins to decrease. This colder water then sinks, and you would imagine that there would be a deep water current that would move along, something like that. In the southern Atlantic Ocean, sea ice releases a lot of this salinity out of it before it actually forms into ice. So this cold water becomes extremely saline, and that increases the density, causing it to sink as well. So what can cause deep water formation? So I briefly touched on it in the last slide, but we'll go into a little more depth here. So the first idea is the thermohaline circulation, that most of the ocean follows this kind of conveyor belt-like idea, with warm water moving up from the equator, where heat brought in from the sun is higher in intensity, and then moves poleward, where it can distribute this heat throughout landmass and through other water. So that can be shortened to THC in my presentation. Note that for future. Um, but back to the topic at hand. Variation in the temperatures of water in this area can change the amount of deep water that can occur. Temperature and salinity both affect the density of the water. Temperature, if it increases, decreases the density of the water. However, salinity, as it increases the density of the water. So both of these things cause deep water formation to slightly change. And another factor that's kind of important is the idea of inertial forcing. As water begins to travel in this path, it creates almost like a feedback circuit. It moves all together, and if one part starts slowing down, all of this water builds up behind it and forces it to continue along its path. So that inertial forcing, it'll keep things going in the general idea of how they were before without much change. So, oh, excuse me. So, decreasing deep water formation can occur for a few different reasons, but the ones I would like to discuss today are these density differences. Um, a few ways to change the density of the water in the North Atlantic where deep water is forming are increases in freshwater inputs and increases in temperature. So one major event that occurred that allowed for massive amounts of fresh water to be added to the ocean was the Younger Dryas event. Back many years ago, there was a glacial period where large ice sheets covered most of North America. These ice sheets, when the glacial period started to resolve itself, retreated and left behind large amounts of water when they melted. This water formed inland freshwater lakes, and the main one that I would like to discuss is Lake Agassiz. This lake was supposedly so big that it covered an area almost the size of the Black Sea at some points. So when a large meteor hit, it allowed for some changes in the terrain, and large amounts of fresh water was able to be input into the ocean through a different channel that was available, and this freshwater increase decreased the whole salinity of the open ocean moving northward and changed the entire Atlantic uh, climate. These changes have been recorded in the Delta 18O and Delta 14C in various foraminifera and in the ocean water itself, and have been recorded in geologic time because of it. And these global changes can be seen in the Keys and calcium carbonate formation, in various foraminifera in the North Atlantic, and they can also be seen in Europe, where this water tends to flow with the Gulf Stream and Canary Currents. So, what can change with various thermohaline circulation? And so, the first thing that would be discussed is how local climate can change. Um, if the amount of heat being brought northward changes due to decreasing or increasing currents, that can change the amount of availability for various species to live, both on land and in the ocean. Um, Potential decreases in mid-latitude upwelling can also occur with the decrease in deep water formation that was suggested earlier. Decreased open ocean downwelling can also occur. So this mid-latitude upwelling is mostly around coastal systems, and if that were to decrease, that would decrease the amount of deep water being allowed out of that channel and system. That would not be too surprising with the open ocean downwelling decreasing as well, because that's decreasing the amount of deep water formation in the open ocean. Um, and with thermohaline circulation changing and potentially slowing, there would be a density stratification increase at northern latitudes that could occur, which would mean there would be a small barrier between the surface and the deep ocean, allowing this water to mix and then deep water to form. So that is a potential positive feedback loop, decreasing deep water formation even more. So what can we do about it, and why should we even care? I'll address the second one of those questions first because I feel like it's really important. Coastal biodiversity and abundance in coastal systems would be greatly affected by a decrease in upwelling. Most of the coast is river fed, but areas that aren't are mostly sustained off of upwelling in these local areas. So if that were to change, if upwelling were not to occur, all these areas where they don't have large amounts of nutrient runoff from riverine inputs would basically become biodiversity pit holes. They have almost no available nutrients, and a lot of the species would have to move in order to sustain themselves. Um, Local climate changes would allow, uh, if the local climate changes were to occur, things like local vegetation on the actual land masses could change and lead to variations in the number of animals and plant life, as well as the kinds of plant life that are actually there. Um, with the northward movement of higher temperatures, the southern species that grow better in warmer temperatures would move northward, overtaking and outcompeting various vegetation, and so on and so forth. Um, Another thing that would become an important thing to discuss is storm intensity and how we track them. If thermohaline circulation were to change, the and deep water formation were to decrease, the potential for storms to sit in slower moving surface ocean currents in the North Atlantic is a huge factor that could lead to massive storms forming. It's not necessarily an increase in the number of storms, but because of a higher temperature water that sits there for longer, there's the potential for great storms to occur, and that would be slightly more difficult to track due to the changes in the actual currents that form in this North Atlantic southern area. So things we can do to change this are decreasing carbon emissions, learning about how glacier and sea ice forms, and potentially allowing these ice and glaciers in the Atlantic to actually expand. There's currently competition for oil and exploration in the North Atlantic. Uh, a lot of ships are breaking up the ice in order to get to different places. This can lead to increase in surface area of the sea ice, which allows for more seawater to actually affect it, and this seawater is at a higher temperature than the actual sea ice, which would lead to melting. So, thank you all for listening in today. This is my works cited page, and I hope you have a wonderful day.